The threat is mainly about freshwater resources. Specifically, we address the hydrological change due to climate change. Climate change refers to the change in precipitation, temperature, sea level, carbon dioxide concentration, etc. The hydrological cycles affected by them can lead to diverse impacts and risks. They interact with the non-climate drivers as well as water management responses. One hydrological change is increased floods in the subtropical regions. Here, India is used to illustrate the issue. India is vulnerable because it's one region that has monsoon, which is easy to trigger floods already. The climate change makes it even more vulnerable to such disasters. According to the 5 CMIP5 climate models and 11 hydrological models, most of India has more than 10% increased change of mean annual stream flow if global temperature rises 2 degrees above the 1980-2010 mean. The CMIP5 simulations of the water cycle also predicted that global mean precipitation increases when global temperature is high, with small variation across region. The CSSR reports that the global hydrological cycle is anticipated to intensify as a consequence of increased temperatures in the troposphere. While precipitation tends to decrease in subtropical latitude, India is likely to have higher precipitation in the future. In addition, the few available studies imply that flood hazards will increase in this region. Consequently, freshwater ecosystems are affected by water quality changes due to climate change and by human activities to prevent flood risks, such as construction of dams. However, the increased precipitation doesn't necessarily mean a bad thing to the community. Water becomes less scarce and farmers will need less water for agriculture. Facing climate change, adaptation is needed with no doubts. Afforestation helps evapotranspiration and helps decrease total runoff. Based on studies by several researchers, afforestation is beneficial to soil erosion, local flood risks, water quality, and stream habitat quality.